All right, guys, so go ahead and grab your notes ready. I handed out 8.3 yesterday in class. We're going to go with the double angle and half angle formulas here. So be sure to stop, pause, rewatch, rewind if needed for the video. And also, you can also watch the LSU video on My Math Lab. All right. So objective one, understanding the double angle formulas here. You have five. You have five formulas. You got one for sine of 2 theta, which means we double it. So sine of 2 theta equals 2 sine of theta cosine theta. We have three cosine formulas here. Just use whichever one is easier for you. All three of them get the same answers. Just pick the easiest one. And we have one for tangent, okay? These formulas were derived from the Pythagorean identities here. So spend some time going over these five formulas so you understand how they work and what do you need to solve each one. Look at our first example here. We got to evaluate the expression as a sine, cosine, or tangent of a double angle, then find the exact value without a calculator. We have the cosine squared of 11 pi over 12 minus the sine squared of 11 pi over 12, right? Looking at your formulas, which one does that match? We have cosine squared minus sine squared, which matches this formula here. Right here, the first one, the first cosine. So you can rewrite that problem as the cosine of 2 theta, which is the cosine of 2 times theta. And we know that theta is our angle. So it'd be theta equals 11 pi over 12. That's our angle. These two are equivalent. So we're going to find the cosine of 2 theta. So we're looking for the cosine of 2 times 11 pi over 12. We're going to do the math, multiply across, so it'd be 2 over 1. So we get the cosine of 22 pi over 12. We're going to simplify that expression, divide by 2 on each side. We divide by 2 on top and bottom. And we get the cosine of 11 pi over 6. All right. Now let's graph this angle. We want to graph it, see what quadrant it lies in. So we're going to graph 11 pi over 6. All right. Remember, a full rotation is 2 pi. So 11 pi over 6 would be in what quadrant? You're right, quadrant 4. Somewhere in there, quadrant 4. That's our theta, our 2 theta. All right. That's theta. So the quadrant 4 is cosine positive or negative. So we're in quadrant 4. And you're right, cosine is positive. Cosine is positive. So our reference angle for 11 pi over 6 is what? This reference angle will be, what's the reference angle? And it should be pi, you're right, pi over 6. So now we want to find the cosine of pi over 6. That should be very easy. This is one of our special angles. Use your quick cheat sheet. And the cosine of pi over 6 equals to what? The square root of 3 over 2. That's our answer. So we know that the cosine squared of 11 pi over 2 minus the sine squared of 11 pi over 2 equals the square root of 3 over 2. That's our answer. So you can go ahead and stop, pause, rewind if you need to. Make sure you understand that problem. The second one. Given that the sine of theta equals 5/7 and it lies in quadrant 2, we want to find the sine of 2 pi, the sine of the cosine of 2 theta, and the tangent of 2 theta. All right. First and foremost, you must understand what's going on here with that angle. With the sine of theta equals 5/7. That's graphing. We know it's going to be in quadrant 2. It says lots in quadrant 2. Think about, we know that sine is equal to what? Y over R. So we got 5/7. So Y is 5. And the R is 7. So the Y is 5. This Y is 5. And the R is 7. We have to find our X. Find our X value. We can use Pythagorean theorem to find the X. But be careful. We know that because it's only negative X axis, the X must be what? The X must be negative. It's going to be negative. All right. So we do Pythagorean theorem here. So we got 5 squared, which is 25. 7 squared, which is 49. So we get the square root of 49 minus 25, which give us the negative square root of 24. We want to simplify this radical. So X equals the negative 2 square root of 6. We just simplify that radical from 24. All right. So now we got our Y, an R, and our X for our theta. Okay. We're going to save some work by finding the tangent, cosine, and sine of our theta. So we know that they give us the sine. So sine of theta is equal to what? You're right, 5/7. The cosine of theta is equal to the X over the R, which equal to the X is negative 2 square root of 6 over the R, which is 7. And the tangent of theta is equal to the Y over the X, which is 5 over negative 2, the square root of 6. All right. But we need to find the double angles, right? So we need to find the sine, cosine, and tangent of the double angle. So we're going to use the sine formula here, right? We know that the sine of 2 theta equals what? The 2 sine of theta times cosine of theta, right? We're going to rewrite it. We get the sine of 2 theta equals 2 the sine of theta times the cosine of theta. Lucky for us, we already found the cosine of sine. So this equals to what? 2 times 5/7, which is our sine, times our cosine, which is negative 2 the square root of 6 over 7. I slow down so you can catch up. Remember, when we multiply fractions, we multiply straight across. So we multiply straight across. So now we get negative 20 square root of 6 all over 49. And we cannot simplify anymore. We're done. Write that a little bit better. Negative 20. All right. That's our sine of 2 theta right there. That's our answer. Now we're going to find the cosine of 2 theta. The cosine of 2 theta. Look at our formulas here, right? We got 3 to choose from. Which one is easier is going to work? Right here. That's the easiest one right now to use. All right, because we already got the sine. So now we're going to write our formula here. So we have the cosine of 2 theta equals 1 minus 2 the sine squared of theta, which equals to 1 minus 2. Remember the sine is 5/7 squared. So we're going to remember order of operations, PEMDAS, we do exponent first. So we square the exponent, we get 1 minus 2, 25/49. Multiply the 2 and we get 1 minus 50/49. And then 1 is the same thing as 49/49. So the answer will be negative 1/49 is the answer for the double cosine of theta. All right. Now let's do tangent here. Let's do tangent. For tangent, you can do two things. You can use the tangent formula, which is up there at the very top, right here. That works. But because we found the sine and cosine already, we know that tangent, let's do a different color, tangent of 2 theta equals the sine of 2 theta over the cosine of 2 theta. That works too. We can just use these two values we found here and here. That works. Let's do that here. So we know that sine 2 theta would be negative equals negative 20 square root of 6 over 49 divided by the cosine, which is negative 1/49. We're going to cross multiply to cancel out the 49s and the negatives, and that should give us the tangent of 2 theta equals to 20 the square root of 6. That works every time. Or you can go back and use this tangent formula here, and you're going to plug in what we found here, which is the tangent of negative 5/2 over square root of 6 over 1 minus that same thing to get the answer. Either way works. All right. So I'm going to stop here for the first objective. Take your time, go back, rewatch it, get all the notes down, and try some practice problems on My Math Lab.